Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble code DTC P2185 related to the engine coolant temperature sensor 2-circuit high voltage for the Honda Accord 2023 and newer models. DTC P2185 indicates that the engine control module, ECM, has detected an abnormal voltage level from the ECT sensor 2, which is responsible for monitoring the temperature of the engine coolant. The signal from this sensor aids the engine control system in regulating engine temperature, ensuring optimal performance and efficiency. The ECT sensor typically operates within a specific voltage range. If the voltage exceeds 4.92 volts, the ECM registers a fault. The faults can arise due to issues with the sensor itself, its circuit connections, or the engine control unit, which processes the signals from the ECT sensor. Proper diagnostics and troubleshooting are essential to pinpoint the exact cause of the DTC and effectively resolve the issue, thus ensuring the vehicle operates smoothly and reliably. The DTC P2185 relates to the engine coolant temperature, ECT, sensor 2. This sensor plays a crucial role in monitoring the engine coolant temperature, reporting this information to the engine control module, ECM, for processing. The ECT sensor is typically located near the engine block, connected to the coolant circuit. Its primary function is to provide real-time data about coolant temperature, which is vital for the engine's performance and emissions control. A malfunction or abnormal voltage reading from this sensor can lead to incorrect adjustments in the air-fuel mixture and ignition timing, which may negatively impact engine efficiency and performance. Understanding the function and location of the ECT sensor 2 is essential for effective troubleshooting of the DTC P2185. Several possible causes can lead to the P2185 error code. First, a faulty ECT sensor 2 itself may deliver an incorrect voltage signal, triggering the DTC. Inspection of the sensor's condition and connections is therefore imperative. Secondly, an open or short circuit in the wiring harness connecting the ECT sensor to the PCM, powertrain control module, could also result in high voltage readings. This area includes inspecting both the signal wire, TW2 sensor, and the ground wire, SG6, for integrity. Finally, if both the sensor and the circuit appear functional, a malfunction in the PCM itself may be the root cause of the issue. Each of these elements must be thoroughly examined to accurately diagnose and rectify the problem associated with DTC P2185. The presence of DTC P2185 can manifest in various symptoms, indicating an underlying issue with the engine coolant temperature readings. One of the primary symptoms may be an overheating engine, as inaccurate temperature readings can prevent the cooling system from functioning effectively. Furthermore, poor engine performance could arise due to incorrect adjustments in fuel-air mixture resulting from a faulty temperature reading. Additionally, drivers may observe a check engine light illuminating on the dashboard, prompting the need for a diagnostic scan. Recognizing these symptoms is crucial for timely intervention to prevent further engine damage or performance degradation. Thus, if such symptoms occur, it may be vital to investigate the underlying issues associated with DTC P2185 without delay. In the first troubleshooting step for DTC P2185, you begin by turning the vehicle ignition to the on position without starting the engine. This action powers the vehicle's electrical systems, enabling you to check the monitoring systems, including the engine control module, ECM. Next, you will use a diagnostic tool, such as the HDS, Honda Diagnostic System, to verify the voltage output of the ECT sensor 2. If the displayed voltage exceeds 4.92 V, it confirms that the failure has been duplicated, indicating an abnormal condition that necessitates further inspection and diagnosis. This step is crucial in determining whether the issue lies with the sensor or the related components in the circuit. In the second troubleshooting step, begin by disconnecting the ECT sensor 2 connector. This isolation allows for a clearer diagnosis and helps pinpoint the fault without interference from the sensor's readings. Following this, you will need to use a jumper wire to connect terminals number 1 and number 2 of the ECT sensor 2 connector. Make sure the jumper connections are secure to ensure accurate readings. Then, turn the vehicle ignition to the on position again while monitoring the HDS for the ECT sensor 2 voltage. Ideally, the voltage reading should now be less than 4.92 volts, indicating that the sensor wiring is functioning correctly. If the voltage stays high, it suggests a potential issue with the ECT sensor itself, necessitating further investigation. During the third troubleshooting step, you will focus on examining the wiring connections for the signal, TW2 sensor, and ground, SG6 circuits. Before proceeding with the inspection, it is vital to ensure the PCM connector is disconnected to avoid accidental shorts or errors during diagnosis. With the ECT sensor 2 connector still disconnected, you will then conduct an open wire inspection for both TW2 sensor and SG6. This inspection determines resistance levels between the terminals. The ideal outcome should be less than 1 ohm, indicating a solid electrical connection without breaks in the circuit. If abnormalities arise during this inspection, further investigation into the vehicle's wiring and connections is warranted to rectify the circuit issues related to DTC P2185. In the final troubleshooting step, should previous checks yield normal conditions for both the ECT sensor 2 and the wiring, the focus shifts to the powertrain control module, PCM. This module is the brain of the vehicle, responsible for managing engine performance through sensor input data. You will conduct a thorough inspection of the PCM itself to verify its operational integrity and performance. If the inspections for the ECT sensor and wiring show no issues, but the PCM is still exhibiting faults, it may be concluded that the PCM is the source of the DTC P2185. Rectifying or replacing the PCM would then be necessary to restore proper operation and eliminate the DTC. After all necessary repairs associated with the DTC P2185 have been completed, it is essential to perform a final repair verification process. Start by clearing the DTC from the diagnostic system. This step resets the system's memory and removes any stored fault codes associated with the previous issues. Following this, it is crucial to run the vehicle and monitor for normal engine functions. During this period, keep an eye on the HDS for any reoccurrences of the DTC or any new codes. Confirming that the engine coolant temperature readings are now within the expected range indicates successful repair. This verification process confirms that the underlying issues have been addressed effectively and ensures the reliability of the vehicle's cooling system. Preventive maintenance plays an essential role in minimizing the occurrence of DTC P2185 and similar codes in the future. Regular inspections of the ECT sensor and its wiring connections can help identify wear or damage before they lead to system failures. Furthermore, routinely checking coolant levels and the quality of engine coolant is critical to maintaining effective engine temperature regulation. Lines and connectors should be kept clean and free from corrosion, as these can adversely affect sensor readings. By establishing a prevention program that includes these steps, not only can vehicle performance be enhanced, but costly repairs and downtime can be minimized. Regular maintenance greatly contributes to the longevity of the vehicle and translates into a smoother driving experience. In conclusion, understanding and effectively troubleshooting DTC P2185 is crucial for maintaining optimal performance in the Honda Accord 2023 and newer models. We explored the role of the ECT sensor 2, its function in regulating engine temperature, and the various components involved in this diagnostic code. Identifying symptoms early and performing structured troubleshooting steps significantly aids in resolving issues promptly and efficiently. Moreover, implementing preventive maintenance practices ensures longevity and reliability of the engine cooling system. As with any diagnostic trouble code, timely diagnostics and repairs are critical in preventing further complications, safeguarding engine health, and enhancing the overall driving experience. Thank you for your attention to these important vehicle maintenance topics. Please like and subscribe to the channel. See you next time!